Hi, my name is Cameron Lee.
And I'm Cameron Carbone.
And this is Group 9's Media Project video for Physics 111.
For our concept, we will discuss the law of conservation of energy.
And we will do this through the idea of a pendulum. You may recognize the idea of a pendulum from a grandfather clock. That right there is a pendulum. A pendulum contains gravitational potential energy as well as kinetic energy. As the pendulum approaches the top of the swing, it reaches its maximum gravitational potential energy and zero kinetic energy. At the middle point of the swing, it possesses its minimum potential energy and maximum kinetic energy, as shown in the graphs on the left. As these forms of energy keep interchanging, there is energy being conserved, and the total energy value stays constant throughout the swing. An important key fact about energy to be noted before looking into the calculations in the graph is that energy is neither created nor destroyed, which means that if one form of energy in a system decreases, it must appear in an equal amount in another form. This is widely known as the law of conservation of energy. This law can be shown through the following equation. The total amount of energy in this system is equal to the sum of the amount of kinetic energy and the gravitational potential energy. Then, from the law of conservation of energy in this system, we get the equation, the change of total energy is equal to the sum of the change of kinetic energy and the change of potential energy. From there, we can rewrite this equation with the forms of energy equations, and that equation would equal 0. Since energy is a scalar, the value of it cannot be negative, which means from this equation, the max of one of the forms of energy means that the other form of energy must be at its minimum, which would be 0. This must mean that the equation must be true, as the max gravitational potential energy is when an object is at its max height, and the max kinetic energy is when an object's velocity is at its highest speed, which is at its minimum height. So, we can set them equal to each other and get the following equations. In order to create our own pendulum, William, with the help of his housemates, was able to use a football, tie it to a rope, and release it from a height of about 3 meters off of the ground and let the swinging begin. As you can see in the video, the football never reaches a minimum height of 0. Therefore, in the calculations, we adjusted the height to get more accurate results by subtracting the height at which it was dropped by how far the football was off of the ground at its lowest point, which gave us a height of 2.71 meters. We uploaded our video into Vernier Video Analysis and traced the position of the football along the swing. Then we were able to determine the following graph, which includes the x and y position versus time values and the x and y velocity versus time values. At the lowest point of the swing, the velocity reached its maximum value, which is the value needed to calculate the kinetic energy. This maximum velocity value can also be located through the data table by finding the lowest determined y position value and looking in the x velocity column found in the same row. These values are in the row highlighted in blue. We then found the magnitude of the velocity, which differed from the value seen here by only 0.01 meters per second. When we plug our values into the previous equation, we achieve the following results. We were then able to transfer the x and y velocity data points over from Vernier into Excel and calculate each individual kinetic, potential, and total energy values. From this graph, we can clearly see the inverse relationship between kinetic and potential energy. For the trend line at the top, which was all of the values of total energy, you can see that it is slowly decreasing. This is why our values are not exactly equal to each other. We were able to determine from the slope of that line that approximately every second, 1.83 joules of energy is being transformed into other forms of energy, like thermal energy in the form of air resistance. It does not disprove the law of conservation of energy, though, because the energy is being transformed into something other than kinetic or potential energy. In a vacuum where there is no air present, like outer space, the energy from potential to kinetic would be completely conserved, meaning that our kinetic energy value would be identical to the gravitational potential energy value. In conclusion, the use of a pendulum helps to prove the physics concept behind the law of conservation of energy through accurate calculations and analysis of the constant transformation of kinetic and gravitational potential energy.
Thanks for watching.